1.2 for us, which is multiplying and dividing integers. And in my opinion, multiplying and dividing is easier than adding and subtracting when you're dealing with negatives because the rules are really straightforward for these. So multiplying and dividing integers, you basically just have two rules. If you have the same sign, you will have a positive answer. And if you have different signs, you're going to have a negative answer. And this applies for both multiplying and dividing, so there's not different rules for those. So, here is where the rules are easier, but I sometimes run into issues here. I'm not going to make you admit it out loud, but I have found that there seems to be an alarming number of Math 1 students who do not know their multiplication tables. Hopefully that is not you. I see some guilty looking faces out there though. So, multiplication tables is something for upper level math you really, 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 really need to know. Because as I go through problems and work things out, I'm not going to take time to type in 5 times 8 on a calculator, right? I need to know it right away. Because I can guarantee you I am much quicker with my brain, and you should be much quicker with your brain than you're going to be if you have to type that in. I realize that the argument that you may not always have a calculator is pretty much not applicable anymore, right? But what I can tell you is that if you have to use your calculator for all of that, it really, 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 really slows you down. And if it slows you down, if you're having to use a lot of brain power to think about what 8 times 5 is, then there's not as much brain power left to figure out how to solve a long equation, or factor a quadratic, or solve a logarithmic equation or something. Some of the stuff you'll get to later along, right? Because if you're having to think really hard on 8 times 5, there's nothing left to finish everything else out. The rest of the class has left you. So you really, really, really need to have them memorized. So, if you do not, we are not using calculators on any of this. So you do not need to cheat and use a calculator whenever you're doing your work yourself. Because if you do, your brain is not learning those multiplication tables, right? What I have found is that what usually helps the most, if you do not know your multiplication tables, is for you to just make yourself do it over and over and don't reach for that calculator. If you're really desperate and you really do not know them well, first of all, you probably need to just do some studying with them, make some flashcards, find an online game or something like that. But if you really do not know them well, maybe get you a multiplication chart to look it up or something, although I'm not going to let you use those on a quiz or a test. But you really need to work on it because it's going to be something that we use a lot, right? We're going to multiply all the time, and we're not going to have time to reach for our calculator. That's why I don't let you use the calculator right now, because if I let you use the calculator, you would, and then you wouldn't remember them, right? And I know last year, Miss Ball probably lets you use the calculator on everything, because I let my kids use the calculator on everything, because you can't say no calculator when you're sitting at home in your bedroom, right? I mean, I could say it, but it wouldn't do any good. So since we're back, it's something we really need to work on. It might be something you're kind of weak on because you didn't get much practice without that calculator last year. So that's my speech about multiplication tables. It's really important that you can do it pretty quickly in your head, right? And we want to know them automatically, so we don't have to waste brain power on that. So we got more brain power for the harder stuff that we're going to be doing. So let's just do a few examples. Let's say we're going to start with multiplying. Let's say I've got -8 times -7. Straight to the 8s and 7s. Those are the ones I always have the most trouble with. So, what have we got, Passion? Okay. Do we have same signs or different signs? Same signs. 56. Good. Which is the opposite of adding, right? If we were adding -8 and -7, we would get a negative answer. But with multiplying, negative times negative is going to give us a positive. So it'll be 56. All right. I'm not going to do a lot of the multiplication table ones. What I do want to look at is what happens if we have something like -42 times 8. -42 times 8. So I'm just going to go back over it real quickly because we would usually type that into a calculator, right? One of the reasons that we're giving you this without a calculator also is not just to punish you. It is because whenever we do have to take that EOC at the very end of the year, it has a non-calculator section. And they put stuff like this on the non-calculator section sometimes. So we just need some practice. Yes? That seems right. I'm going to do it over here to make sure you're right, because that one I can't do right off the top of my head. So you got 16. Okay. Okay. So we do 8 times 2, we'll get 16. We'll carry our 1. Then 8 times 4 is going to give us 32. And then we'll add one more, 33. So 336, and it will be negative. You remember how to multiply those 2-digit numbers? Yeah, so like this one. You're also going to see a little bit of this. This is where we really might need a little refresher, because even though, let's see, my son's going to be in the 5th grade. I don't think he's done problems like this. I know he hasn't done the negatives, but the negative rule's not that bad. It's the multiplying that gets us sometimes. So 52 times -24. Now, the negatives we can kind of ignore because we know negative times negative is going to give us positive. So we can think about the sign of the answer without even worrying about the numbers, right? So whenever you're multiplying 2-digit numbers, just a quick refresher. Some of you I know already know this, so it's not a big deal. Also in Math 1, we typically either use parentheses or the dot. We typically do not use the X. Typically, although the worksheet I'm getting ready to give you does have an X on it, because it's just kind of hard to type the dot. So we typically don't use the X because we're going to get into algebra where we're using X's as variables. So we usually use a dot instead, or the parentheses. All right, so when we're multiplying, we start with that 4. 4 times 2 is 8. And then 4 times 5 is 20. What do we do now? I'm going to let you tell me your different way in a second, Passion. So we're going to put a 0 right here for our placeholder because now we're multiplying in the tens place. So we got to put a 0 there or at least skip a spot. But I like to put the 0 so I don't get mixed up. And then you're multiplying by that 2. So 2 times 2 is 4. And then 2 times 5 is 10. And now we can add these two together. So we got 8, 4, 2, 1. So we get 1,248. What do you do, Passion?
So I'll take the fifth of the largest number, the 50 different sides, and then I'll put 24, you put the 20 right there, and put 40. That's all.
Okay, I got you. So, okay, I see what Passion's doing. She's basically splitting one of her numbers apart, right? So this is what she's doing. It's kind of a cool way to do it. Like 24 is the same as 20 and 4, right? So she's doing 52 times 20 and 52 times 4. And so 52 times 4 is just like that first step. You got your 208 right here, right? And then you can really just multiply the 2 and you know you'll have that 0 there on the end. So this is going to give you that 1040, and then you add those together. So it's kind of the same thing, but you're splitting it apart, and that's a good way to think about it too.
Every time I did that way, I'll end up getting it.
Yeah, if you forget to carry something or mark something out, splitting it up might help you if you have trouble with that. So that works well also. All right, questions on multiplying? All right, let's do a little dividing. Let's do some fun ones here. Let's do negative 45 divided by 9. I am typically going to use the fraction bar as my division. Because we just see that a lot more in algebra here. So, negative 45 divided by 9, what do we get? Negative 5, right? That's basically just knowing your division, opposite of your multiplication table. Now, here's what I hear sometimes grown adults admit they don't know how to do. What if we have... I better make sure I'm getting one that's going to go evenly. What if we have negative 475 divided by 5? Unless you have exceptional mental math skills, you probably can't do that one in your head, right? So, long division has got to come out here. So, whatever number's on the bottom is the number that goes on the outside for your long division. Ignore your signs because we just know the answer is going to be negative for this because we got a negative over a positive. So we got 475. And so for long division, we're going to ask ourselves, does 5 go into 4? Doesn't go into 4, right? So 5 goes into 47 how many times? 9. So then we have to 45 multiply 9 times 5 is 45. Subtract, we get 2. Bring down, we get 25. Everything I'm giving you today should go evenly, although it won't always go evenly like in everything you run into. But 5 goes into 25 5 times. 5 times 5 is 25. Subtract 0. That tells you you're done. There. So we would get, in this case, negative 95 for our answer. All right, let's do one more that's a little bit harder, and then we'll let you guys work on this worksheet that we're going to do for classwork. Alright, so let's do negative 728 divided by negative 26. So multiplication and division, ignore the signs. Just think about what the answer is going to be, right? If I've got negative divided by negative, it tells me my answer is going to be positive. So I'm not thinking about the signs past that. So I've got 26 here and 728. So I've got to ask myself, 26, will it go into 7? No, it will not. How many times will 26 go into 72? 2. Okay, so 2 times 6 will be 12, carry your 1. 2 times 2 is 4, 5. So 50, oh wait. 52. Is that right? Yeah. And so we need to subtract. Oh wait, hold on. When I subtract, no, this is right. Okay, I get 20. And then I have to bring down the 8 right here. How many times do you think 26 goes into 208? What? You think it's going to be 4? Let's see, 4 times 25 would give you 100. I think it's going to be more than 4. Let's see. 25 times 8. Yeah, I think it's going to be 8. So this can be kind of difficult because it's not quite as easy to see, right? Sometimes you might have to kind of guess and check if it's right. So if you multiply and you get, when you subtract, you get a number bigger than 26, you know you could have used something bigger. All right, so 8 times 6 is going to give us 48. We're going to carry that 4. 8 times 2 is 16. Plus 4 will give us 20, which is 208, which will give us 0. So 28 is our answer. Okay, questions? Okay, so I have a worksheet that I'm going to give you guys. This is going to be classwork, and then depending on how far we get, there's going to be, we'll go over it, and there's going to be a different one that is your Alright, no calculators on this, so make sure. Several of these you might not need to show work on, but when you get down to some of the longer ones, I want to see some work, because if you can do 125 times negative 23 in your head, then you're in the wrong class. You should be in some sort of honors class. Make sure your phones are away, like in your book bag or your pocket, not out on your desk. You can't have that phone with that calculator on there. That's too big of a temptation right there. Or Snapchat or whatever else you might need to check. Okay.